Confused by sieve analysis? Let's fix it with one full numerical step by step. The results of a sieve analysis done on 900 grams of a soil are given below. Draw the particle size distribution curve and determine the uniformity coefficient and coefficient of curvature. Sieve sizes and mass of soil retained on each sieve are given in the table. In order to solve this, we should first know how to tabulate the given data. Arrange the sieve sizes from the largest opening at the top to the smallest at the bottom. The mass retained on each sieve is then entered in the second column. Next, calculate the percentage retained, followed by the cumulative percentage retained, and finally the percentage finer. These percentage finer values are the points we use to plot the particle size distribution curve. Next, we calculate the percentage retained on each sieve. Let the total mass of the soil sample be M, and let the mass retained on each sieve be M1, M2, M3 and so on. The percentage retained is calculated by dividing the mass retained by total mass multiplied by 100. Repeat this calculation for every sieve in the table. First, calculate the percentage retained for the first sieve. 35 gram is retained out of total 900 grams. Then 35 by 900 into 100 equal to 3.89. Similarly, 40 by 900 into 100 equal to 4.44 and so on. Repeat the same for the remaining values. Then calculate the cumulative percentage retained. Cumulative percentage retained is the total of percentage retained values from top to bottom. C1 equals P1, C2 equal to P1 plus P2 and so on up to the last sieve. First sieve gives 3.89%. For the second sieve, we add 4.44 the previous 3.89 to get the cumulative percentage retained as 8.33. For the third sieve, we add 8.89 to 8.33 to get 17.22 and so on. Percentage finer equal to 100 minus cumulative percentage retained. Therefore, percentage finer N equal to 100 minus 3.89 equal to 96.11, 100 minus 8.33 equal to 91.67, 100 minus 17.22 equal to 82.78, etc. How to plot the particle size distribution curve? Take the sieve size on the logarithmic x-axis and percentage finer on the y-axis. Plot all the points from the sieve analysis table and join them with a smooth curve. This gives the particle size distribution curve of the soil sample. From the particle size distribution curve, we can read D10, D30, D60 values, which represents the particle sizes at 10%, 30% and 60% finer respectively. From the particle size distribution curve, D60 equal to 1.55 mm, D30 equal to 0.53 mm and D10 equal to 0.115 mm. From the particle size distribution curve, we calculate two important parameters, uniformity coefficient and coefficient of curvature. Uniformity coefficient Cu equal to D60 divided by D10. It indicates the range of particles present in the soil. A higher Cu means the soil is more well graded. Here Cu equal to D60 divided by D10 equal to 1.55 divided by 0.115, Cu equal to 13.48. Coefficient of curvature Cc is D30 square divided by D60 into D10. Therefore, Cc equal to 0.53 square divided by 1.55 into 0.115 equal to 1.58. If you found this video helpful, make sure to like the video and subscribe the channel.